Hey there, back with the Bay Tank job. I just wanted to explain what happened. So, all right, with this one had complex curves with this filter pit, and it's got like a little step up inside. See that? That's for his lid for the filtration. So, as it turns out, the way this all went down was I had to break the mold apart. And there's a couple of reasons, but the main reason is the when I discussed how the plug or the mold was built originally that I was supplied with. This was my first time doing this, so I wasn't familiar with all the do's and don'ts of making a mold. So what it was the mold was made of Bondo on the exterior. That was the hard shell, which is the positive side, and that you can't. I mean, you can, and it did separate, but it had to be manually by hand after the majority of it separated from the air valve. And the air valve worked. It did. You could hear it crack and pop. The thing flexed. Things moved. I was able to actually visually inspect, and it did separate like 80%, maybe even 90%. A lot of it separated, but there were parts that hung up. And I don't know if it was because of the fact that it was Bondo and it didn't have the mold release, or if it was the fact that it just had so many complex curves and there could have been pinholes in the Bondo that actually the epoxy seeped into, but I had to break it out by hand. Um, One thing I will say about this that I learned is that so when you go to make your positive part, your mold, you need to fiberglass it like a surfboard or a boat, but it has to be like finished, and that way it's got a solid, consistent thickness and shell around the foam. The Bondo, it just wasn't possible to get the Bondo even because he did a method that was the best he could do, and it was good. It got the part done, but it he stacked pieces of foam, and it was kind of like, imagine like the game Cubert where there's three-dimensional cubes stacked, so there's inside and outside corners exposed. And even though he shaped it like the rough shape and maybe knocked some of the corners down to get the shape, that in turn left the Bondo thicker and thinner in parts. It's probably pretty easy to imagine that. So anyway, man, this is like just had to break it apart. That is what it is. Came out great. These are for reinforcement because the walls flex. Uh, Gosh, there's probably so many things I could go over about what else could be used, or in addition to how many layers. I mean, this is almost a quarter-inch thick chop strand mat, and 6 and 4 ounce glass, and there's Kevlar strips. But what I found is that this is a big part. This is like 37 by 17. I can't remember exactly, but roughly something like that. And so, and depth is like 20 inches almost. So, and then this part here, everything needed reinforcement. So I bonded plywood with structural epoxy and then glassed over it and the edges. So everything is waterproof. And it's rigid. So now before we go to install and put the part into the compartment, and I don't know how the backfilling of the foam is going to go because I'm trying to wrap my head around how that's all going to work out with the plumbing hooked up. I'll see. We'll figure it all out. But I know I needed to make this rigid enough that when it's put in, and if we don't succeed with the pour foam as a backing in the compartment, which would expand and fill all around it and up to the bottom, etc. I wanted this to be sure that we weren't going to fail when we put this in, and when it's filled with water that it wasn't going to flex too much. So that's what the wood is all about. Okay, so here we go. This one is that's the second part. It's just a basic shape. This was just what the customer wanted. He's not doing all the filtration stuff. So did not have what's considered complex curves. All I did on this was took EPS foam and shaped it based on measurements, and then the radiuses were just a matched radius outside of a bucket, 5-gallon bucket. Now from the flange, which is the top, because this is upside down right now, from there to the bottom, I did a 1/2 inch difference. I think they call it draft. And so anyway, and then I cut the hole through with a drill and glassed my valve on in the center where you see this is actually going to be a drain pit. So inside, that's just a low point. And I did that with Kevlar, chop mat, and fiberglass and structural epoxy. So that's basically how it all went down with this one. And then so on the plug, like I said, I fiberglassed it like I would glass a surfboard. Flat, smooth, clean, perfect. And then so here's the trick. You can use the PVA, polyvinyl alcohol, which is sprayed on, and it's a water-based release agent, and it does work. But what I found out is that the I guess the tried and true method is to use the paste wax. It's got silicone in it. It's a mold release. I did like 8 coats, and what I'll say about that stuff is it is handwork. Apparently you're not supposed to use your machine with the lamb's wool because the technical support that I got on the product said that you would take the material out of the pores in the fiberglass. I'm not going to argue about it. It doesn't really make sense because it's dried and it's on the material, and I would think you're just buffing it. But I just went with it and eventually just did it by hand because originally we started off with compound and polishing the dried paste wax. He says no after I called to double check. So the last 6 coats I did all by hand. So you put it on with like a towel, or excuse me, a wet sponge, damp sponge. Put it on even, wait for it to haze over 15 minutes. Wipe that off with a cloth, and then you hand rub. And that's what they mean by polish this stuff. Apparently they don't mean put your lamb's wool bonnet or polyurethane pad on your sander polisher and do it that way. They want you to do it by hand. So I'm going to say this came off extremely easy. Although it was a simpler plug, but it's still a big part. I was so impressed with how easy this came off. The way we did it was simple. Hooked up the air supply. I didn't even test it. I didn't even pressure test it. I just opened it up and went for it. It started cracking and popping. It had leaks around the valve, but it didn't matter. Apparently those leaks sprang up from the pressure and got through. So it was enough to get it to pop and break the vacuum. That's all you're doing. You're not really like forcing it to separate per se, because there's a vacuum and it's not bonded to the plug. It does not stick to silicone in this paste wax. So this is all the shit I learned taking on this project. It worked like a champ, and I would do it that way 100%. It's just that you have to build the mold right from the beginning. And that's the end result, and it came out beautiful. Kevlar reinforced on the flange. Chop strand mat, 6-ounce and 4-ounce glass, epoxy resin. Nice stiff walls from the wood I bonded onto it, and I'm really happy. We'll get you a video when they're all plugged in and running. Maybe I'll do a little bit of the install, but I'm about to get these things painted with LP paint, a nice blue, so the bait calms down. They say it soothes the bait. So we're going to get these things painted. I'm just drying them right now. I just did my final sanding, pointed up some crap, little voids and things like that, and pinholes, and just got it nice, and now I washed them out and they're drying, and I'm going to spray them with LP paint. 4800 from Proline Paints over at Sherwin-Williams. It's a two-part, highly sought-after finish on boat parts, exterior. You can do it on this because it's not submerged in water all the time. They say don't use the 4800 if it's below the water line because it's submerged all the time. This you can use it on because this is just for temporary filling and running bait, and then it's drained and dry. So all good on that. That's no problem. It's a good application. All right, thanks for watching.